In this video, we're going to look at some examples from section 8.2, where we will perform hypothesis tests on the difference between two means from independent samples. Okay, and where the standard deviations of the populations are both unknown. So it's important to note that before we do the hypothesis tests in this section, that there are certain requirements that the data must meet. Okay, so because we are comparing the means from two different populations, okay, we're going to collect two different samples, and in this section we're going to assume that the two samples we collect are independent. So meaning that there is no relationship between the individuals in the first sample and then the individuals in the second sample. Okay, so here are the requirements. There are 4 of them. So the conditions necessary to perform the hypothesis tests in this section are: 1, the population standard deviations are unknown. Okay, 2, the samples are randomly selected. Okay, 3, the samples are independent. And then 4, the populations are normally distributed, or the sample sizes are both at least 30. So if either of these 4 requirements are not met by the data that we collect, okay, we cannot use the method discussed in this section. Okay, so just like in the previous chapter, we're not going to reference any of the complicated formulas in this section and in the rest of the chapter. Okay, so we're going to use StatCrunch to do all the number crunching for us. Okay, so now that you understand the requirements, you are prepared to answer question 1 on your own. So I'm going to go ahead and skip question 1. And I'm going to go ahead and go to question 2. Okay, and question 2 says, a pet association claims that the mean annual cost of food for dogs and cats are the same. Okay, so in that first sentence, we're going to determine the null and alternative hypotheses. Okay, let's continue. So the results for samples for the two types of pets are shown below. Okay, so this is a summary of the sample data. Okay, so we randomly collected a sample of dogs, and then we randomly collected a sample of cats, and then this is the information for both samples. Okay, so at a significance level of 0.10, can you reject the pet association's claim, okay, that the mean annual cost of food for dogs and cats are the same? Okay, that's the claim. So assume the population variances are not equal, and then assume the samples are random and independent, okay, which they should be, and the populations are normally distributed. Okay, so in part A, we're going to identify the claim and state the null and alternative hypotheses. Okay, so remember the claim was given in the first sentence of the problem. So the question asks, which is the correct claim? Okay, so you want to read these carefully on your own and select the best answer choice. Okay, it looks like answer choice D. Right, the mean annual costs of food for dogs and cats are equal. Okay, in other words, the mean annual cost of food for dogs and cats is the same. Okay, then in the next part of part A, right, we're going to state the null and alternative hypotheses. Okay, so remember, this is the claim that was given in the problem, right? The mean annual cost of food for cats and dogs are the same. So before we state the null and alternative hypotheses, okay, it's important to understand what each symbol represents. Okay, mu1, mu2. Okay, so we know that in the previous video, right, this is the mean of the first population, and mu2 is the mean of the second population. But in the context of this problem, okay, since the dogs are mentioned first in this table, and the cats are mentioned second, okay, we're going to let mu1 be the mean annual cost of food for one dog, okay, and then likewise mu2 represent the mean annual cost of food for one cat. Okay, so even though the problem doesn't mention this, right, you want to know what each population mean is. Okay, so in other words, mu1 or mu1, the mean of the first population will always be the mean of the first group mentioned in the problem, and then mu2, the mean of the second population, will always be the mean of the second group mentioned in the problem. Okay. So the claim was that the mean annual cost of food for cats and dogs are the same. Okay, it doesn't say greater than or less than or not equal to, right? If it had said like less than or greater than or not equal to, right, then you would select the appropriate symbol to go into the alternative hypothesis. Okay, but because the claim says that the two means are equal, right, the mean cost of food for cats is equal to the mean cost of food for dogs, okay, then you're going to use the equal to symbol in the null hypothesis. Okay, that's always going to be the case, right? If the two population parameters in question are equal, okay, in the claim for the problem, right? If the claim says that the two population parameters in question are the same or equal, right, you're going to put an equal to symbol in the null hypothesis. Okay, but if you had seen the words either less than, greater than, or not equal to, right, put the appropriate symbol in the alternative hypothesis. Okay, so now that we figure out the symbol in the null hypothesis, right, what do we put here in the alternative? Okay, so you put the opposite symbol in the alternative. So the opposite of equal to is not equal to, right? So not equal to would literally be the not equal to symbol. Okay, so that becomes the alternative hypothesis. Okay, so the given claim in the problem, okay, is actually the null hypothesis. But in most problems, right, the given claim will be the alternative hypothesis. Okay, so let's go ahead and select the best answer. So the null hypothesis is that the two means are equal, right? So when the difference between the two means is equal to 0, right, that's like saying the two means are equal, right? If there's no difference, right, mu1 minus mu2 is equal to 0, right? No difference. That means the two means are equal, right? And then the alternative hypothesis is that the two means are not equal to each other, right? So if the difference between the two means is not equal to 0, right, it means that there is a difference between those two means. Okay, and then it says which hypothesis is the claim. Okay, so that's obviously the null hypothesis, meaning that the two means are not, or the two means are the same. Okay. Okay, so here it's asking us to find the critical values of this test. Okay, so unfortunately in this question we're not going to use the p-value approach. Okay, so when it tells you to find the critical values, right, what that means is you're going to use the appropriate probability distribution or distribution calculator in StatCrunch to get the appropriate critical values. Okay, and then you're going to enter this information in StatCrunch to get the test statistic, and then you're going to compare the test statistic to the critical values, and then determine whether the test statistic falls in the rejection region to determine whether to reject or fail to reject the null hypothesis. So this will all make more sense as we go through the example. Okay, so unfortunately this is a critical value approach to the problem, okay, which is a little more confusing, but let's go through it. So again, anytime you're asked to find the critical values, right, you want to know whether your test is left-tailed, right-tailed, or two-tails. Okay, so the left tail, right tail, or two tails tells you where the rejection region or rejection regions are for this test. Okay, and determine whether the test is left-tailed, right-tailed, or two-tailed, you look at the symbol used in the alternative hypothesis, right? So you always look at the symbol in the alternative hypothesis. All right, so because it's the not equal to symbol that's being used, right, that automatically makes it a two-tailed test. So this is a two-tailed test. Okay, if this had been a less than symbol, right, then it would be a left-tailed test. Okay. Right, so if the less than symbol was here, this would be left-tailed, right, and the symbol points toward the left. All right, if this were a right-tailed test, right, then you would see the greater than symbol. Notice that the greater than symbol points toward the right. Okay, but because it's not equal to, right, there are going to be two tails. So there are going to be two rejection regions. Okay, so according to the problem, our significance level was 0.10. Okay, so we're going to go to StatCrunch to find those critical values. Okay. So again, when you perform a hypothesis test on the difference between two means, all right, and you assume that the standard deviations of the population are unknown, right? You're going to we're going to go to Stat Calculators and click on T. So we're using the T distribution to find the appropriate critical values. Okay, so that loads the T distribution calculator. Okay, so because this is a two-tailed test, you're going to select the between option. All right, and the important issue here is, okay, what are the degrees of freedom? Okay, so that's what makes it a little more confusing here, because you have to know the degrees of freedom. Okay, so let's go to the book really quick. So again, we're assuming that the standard deviations of the populations are unknown. Okay, so we're assuming that the standard deviation of the annual cost of food for cats and the standard deviation for the annual cost of food for dogs, okay, are both unknown. Okay, so right here at the bottom of this box here on page 428, right, it tells you what the degrees of freedom is. Okay, so remember, we're dealing with two samples, right? So N1 is the size of the first sample, and N2 is the size of the second sample. Okay, so the degrees of freedom would be the smaller of N1 minus 1 or N2 minus 1. Okay, so what that essentially means is, right, if you're asked to find the critical values and you want to know the degrees of freedom for this type of test, okay, you look at your summary statistics, which are given in this table here. It tells you that the size of the first sample is 18 and that the size of the second sample is 8. Okay, so for this type of test, if you want to find the degrees of freedom, you take the smaller sample size and subtract 1 from it. Okay, so always a smaller sample size. So 8 minus 1 is 7. Okay, so our degrees of freedom is 7. Okay, and that goes here. All right, and we're going to put, so to get the appropriate critical values, right, we're going to put 1 minus 0.10, okay? So it's going to be 1 minus the significance level, okay, in order to get the appropriate critical values. Okay, so remember there are two critical values, right? One is negative, one's positive. Okay, and they're both essentially the same number. Okay, we're going to round them to 3 decimal places. Okay, so that first critical value is negative 1.8946. So that 4 there is going to get rounded up to a 5. So negative 1.895 and then positive 1.895 are the two critical values. Okay, so when you look at how this is shaded, this isn't shaded properly, but basically there are two rejection regions, right? So the first rejection region is to the left of the first critical value, so this is the left tail. Okay, likewise, the other rejection region is to the right of the other critical value, which would be the right tail. Okay, so there are two rejection regions, right? One in the left tail, one in the right tail. So the first one is less than or equal to this value. The other rejection region is greater than or equal to that value. Okay, so again, select the appropriate answer choice. So it's not between the two critical values. It's definitely not one of these, because this would imply that these choices would imply that this is either a left tail test or right tail test. Okay, so it would actually be this option here. Okay, so the left tail and then the right tail. All right, so now we want to find the test statistic. Okay, so in order to get the test statistic, we're going to go to the stat menu. Once again, go to T-stats, and because we have two samples, we're going to select two sample. And because we have a summary of the two samples, we're going to select with summary, and then enter the sample mean, the sample standard deviation, and the sample size for both samples. And I'll go ahead and do that off camera. Okay, so remember, this is the mean, standard deviation, and then sample size for each sample. And I've entered that information into StatCrunch accordingly. Okay, then you select the appropriate symbol in the alternative hypothesis, which is not equal to. Unfortunately, you can't change this symbol. It's always going to be equal to. Okay, we're going to click compute. All right, and we're looking for the T-stat, which is our test statistic, so 2.152. Okay, so enter it rounded to 3 decimal places. And we'll continue with this example in the next video.